Math Module 3, Lesson 17. Here we go. More division, guys. All right. Folks in class, you guys did this for one already. Tell me, maybe somebody can help me. Who's Zeta? What do you got? So you've got to put a...
2 above the 5. Oh.
Okay, so...
Write 5 in the box.
So you use the first number to show the 5 dots. 1, 2, 3, 4, 5.
Squiggle line.
I like that because it shows that it's not part of the problem down here. It's like its own number. Cool.
Then split it into 2.
Gonna break it in 2. Nice.
I'm going to put 2 on top and 2 on bottom.
Sure, excellent. So you could do it one at a time and keep drawing them like this.
Or you could do 5.
And then you could say that's the remainder out here, right? R1.
So
The fast way, what you said was just to look at, you got a couple that'll go down here and you got one. Now to represent it over here, Jackson, talk to me about this. It's 2 goes into 5. 2 times. You've got 2 of them here. Okay, so it's 2. It looks like it's going to be groups of 2. Groups of 2. Okay, so 2 times 2. You're using up all 4 dots here. 1, 2, 3, 4. And the remainder? 1. Okay, R1. So the quotient is 2. The remainder is 1. Yeah. Oh, excellent. Oh, yeah, that one. Yeah.
I've never seen those before.
I think if you have just on math drills, yeah, that's a good one. That's a good one to go to. There's lots of good ones on math drills. Thank you, Mrs. Flint.
You're welcome. I think your kids will enjoy it. So I did it one time untimed, and then I'm going to time them and see what they can do to show parents
To
both
show
ways.
both ways, yeah. If they're quick enough to know them by heart.
today.
Oh,
Who said that?
that was nice. Oh, she's
You can come
sweet.
to my room anytime.
Yeah.
Yes,
Mrs.
you're
Flint,
better.
Ariana, like I said.
All right, we're coming back to it. Checking our work. We got the 2 times 2 is 4, but that doesn't give us back to the 5. What does? Adding the
1.
remainder back in, adding the 1 back in gets it to 5. Give yourself a star. Did anybody try number 2 already?
I did.
Okay, let's find out what you got for this one.
I was
So that's a lot of dots. Luckily they're not all 1s. They give us a tens place, so all we have to do is draw in here. We just have to draw our original number, which is 5 tens. 1, 2, 3, 4, 5. And we're going to split this into half. All right, so you probably got 2 here, and those 2 here. Then you've got one of these tens left over. You can't put a remainder 10, right? Because the number is dividing by 2. You can't have a remainder bigger than the divisor.
So you're going to have...
So do I have to take this and turn it into 10 ones?
Yeah.
Okay, so I'll take this and I'll throw it over here and call it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll split this in half. I bet there's going to be 5 here and 5 here. What do you think? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And another 1, 2, 3, 4, 5. Yeah. So half of 10 is 5. So I've got 5 in this spot, and so I divided them in half. So it looks like my answer does not have a remainder. It should be 25. That's my answer. I'm going to get groups of 25. 2 groups of 25. If I add the 25s back together, I should get all of my groups of 50, which is that number there. Let's show it over here, though. Does 2 go into 5? Yes. 2 groups of 2, or you're going to use 4 dots, right? 2 times 2 is 4. Subtract, I'm going to pull out a group of 10. 1 group of 10 in the tens place. Ah, gotcha. So there's my 10 ones. Mr. Yickle. Yeah, what you got? Film the video here, I just paused. Okay, so you said if I get the 1, that can't be the remainder because it's actually in the tens place. It's 10 ones. So we have to bring down and show that that's 10 ones. 2 goes into that 10. We divide it into groups of 5 because 2 times 5 is the 10, which shows I used them all up with no remainder. Weird, huh? Let's take a look.
What's the quotient?
Well, the quotient will actually just be 25 on the top of the house, right? The answer's surface is on the top, and there is no remainder.
So check your work. What would you do?
Yeah, so to check the work, we're going to say that 2 groups, so we're going to say are 25. I always do it kind of like this. I told Lily yesterday, I always kind of do this arc where I kind of look and say, okay, so it's 2 times 25 plus the remainder, which we have no remainder now. So 2 times 25 is all I have to do, or 25 on top times 2. A lot of people know 25 times 2 is 50 because they know coins. You know change, so 25 cents plus 25 cents. So the answer is 50. You could do 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5, and answer it that way. So yeah, we got back to our original 50 inside the house. So there's the 50. All right. You guys okay with that? Am I going too fast? Lily, was that all right? Okay. We'll look down at this one. Looks like an easy one. Does it? Are they doing 3 because 4 has part of it in it? Yeah, I think because they, next one, number 4 is 75 divided by 3.
Wait, Mr.
So
Miller,
they're showing us
we don't
part.
have 75.
Yeah, we do on number 4.
Oh.
They're showing us that, I think they're doing this in steps. So number 3 shows us if we got 7 divided by 3, we can do, maybe relate it to the other one. We'll see. Okay. So we are going to show the 7 dots. 1, 2, 3, 4, 5, 6, 7. I'm going to draw a line and say that's separated. That's just the number. We have to divide it in 3. So if I draw those 2 lines, I've got 3 individual boxes. Now, some people are like, okay, so groups of 2. There's 2, and there's 2. So I got 2 here, smiley face, smiley face, smiley face. So we can say those 2, those are groups of 2 that work. So I can keep moving groups of 2 down. Another group of 2 works down here, and another group of 2 works down here. Also, you can, if you wanted to, just check them off, draw lines through them, and keep going until you have even like dealing cards. Looks like there's one remaining dot that doesn't get to go with a group because you throw off the numbers, and we can't put him just anywhere, so he's a remainder of 1. Now, are they? Did they want us to show the division, or did they give? Oh, they set it up for us. Okay. All right. So I'm looking over here. It is 7 in the house. Divisor is the last guy. He actually is going to be outside here. So 3 goes into 7. I'm saying he's going in twice because as close as I can get is to use 6 dots over here. 2, 4, and 6 dots are used up to try to get to 7. We're going to have a remainder of 1 left over. Now, I do this arc, and I said to Lily yesterday, I said, when you want to do the check, just think, okay, I got to go right along this line, and I'm going to get 7 back. But what do I have to do? I have to do 3 times 2 plus 1 should equal 7. If it does, it's all good. Okay. To show it in a long form, though, over here in the check box, you can do it in a little longer form. Quotient is 2. The remainder is 1. It's 3 times 2 equals 6 plus the 1 equals 7. So 3 over here times the 2 plus the 1 remainder gets me to 7. You had a question? Yeah, Lily.
I'm on the next one. I don't get it.
Okay, I think this one looks good, so we'll go to the next one. It's number 4. So we're going to put our 10s and 1s up here. We got 7 of the 10s and 5 of the 1s. So 1, 2, 3, 4, 5, 6, 7 1s and 5 1s. 1, 2, 3, 4, 5. Draw my little line here. Pick a different color. All right, so I'm going to break these up into groups of 3. There we go. That look right? So far, are you with me on this part? Okay. Did you cross them off one at a time? Just go. I go 1 there, 1 there, 1 there, 1 there, 1 there, 1 there, and all of a sudden, did you have that last one?
Yeah.
Okay. Well, he has to get kicked over to here and become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The reason is he can't just be a remainder in the 10s because he's that would be a lot of, if you think back to like kindergarten, that's a lot of little sticks in a cup that need to be divided into groups. If we left 10 cookies on a plate and we're dividing in groups of 3, a lot of kids would be mad and say, you got a remainder of 10 cookies. Oh no, well 10 could be called 10 ones also. So okay. Yeah, so I got 10 cookies. I actually have 10 plus this 1, 2, 3, 4. I got 15 cookies still left. I've divided up some of them, but I still got 15 over here that need to be divided into groups of 3. Some people would be like, oh, 15 is divisible by 3. There's going to be 5 in each one of those groups. Yeah, 5 in each one. So I pick a different color here and cross them out. And
I don't get how
1,
you do like the triangle thing.
2, 3, 4, 5. There's 5 that could go down here. Okay, there's 1, 2, 3, 4, 5. Here's another 1, 2, 3, 4, 5. They can go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. We can hit it exactly. If you were stuck, you could just do them one at a time and just divvy them up like cards. Say one goes here, and keep moving them down.
I only understand when there's one digit right here.
Yeah, well, let's look at this one. That's why we have to look at these, yeah. They want us to check and see, can we do double digits? Well, I'm going to tell you right now, it's a little bit like this, Zeta. Actually, we have a problem. Our first problem just says, does 3 go into 7? So this problem right here, really just start with this simple fact, what's the first question? They're outside right now. Does 3 go into 7? How many people? Yeah? Can you get close to 7 using 3? Okay, how close? 6. Okay, I know you can get to 6 because you can multiply it times 2. Well, let's superimpose that, or put it right on top of this problem. 3 times 2 is 6. So we can use the same thing you use for single.
Line in between though?
Between the two?
Yeah.
You want to draw a line down through here?
Yeah.
You could, but mentally I think you could, if you needed to draw a line down and just to keep them separate, you could. Okay. Did anybody else want to do that method?
No.
I just know it's down below
I
here.
was just asking because that's what you did yesterday.
Gotcha. Okay, same thing here. We subtract 7 minus 6. We have a remainder of 1. Over here we're going to have a remainder of 1, but we're not done. That's why I don't put remainder 1 yet. We have to do that special thing that makes this number what? 15 over here. How do we show this 15? Well, do you know there's 15 dots we're going to use up over here?
Yeah.
They're actually going to show up in this number right here. When you bring the 5 down, you're going to make the 15. So this section of 15 shows up over here. You're like, oh, wait a minute. We're going to break the 15 into groups of 3. Ah, you know the answer already because you wrote it down. There's 5 in each group of 3, right? So 3 times 5 is the 15, and you get it exactly with no remainder.
There's not much you can do about it now.
What happened there, kid?
She lost the front of her.
We're back. So, Zeta, talk me through this. We're bringing down the 5.
We're bringing down 5, making it a 15, subtracting 15.
Yeah, we have to ask yourself, how many times can 3 go into 15?
3.
Oh. How about 5? 3 times 5 is 15. And why are we subtracting this last time? Just to check and see?
Just so that you can show your work because people can't look inside your brain.
Yeah, and you got to show that you get nothing as a remainder, right?
Yep.
Okay, the quotient is the number on top.
Which is 2.
Well,
Which is what? 25.
25. Is there a remainder?
I didn't write down 5. 0.
0. Now I'm going to draw this arc because this is what you're going to do. Just multiply. This is going to be your check. 25 times 3. 5 times 3 is 15. Carry the 1. 2 times 3 is 6 plus 1 is?
70.
75. Is that the number we started with?
Yep.
That, and you give yourself a star and you say that's good to go.
Of course we got a star.
This is the one you like next, Zeta, though. It's a single digit one.
Yes.
Yes, you love these. But you notice what they're going to do? They're going to do the same problem using 9 in the tens place. Yeah, they're going to start easy and then they're going to make it harder for you.
You can only
9.
put 1 4 into 9.
So let's draw our 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Draw 3 lines.
Wait.
That will break it into 4 pieces. 1, 2, 3, 4. You guys are ahead of me, aren't you?
Yep.
Yeah. Well, let's see. Why don't we just do the slow method? There's that 4. Are there 4 more? 1, 2, 3, 4.
I always have to do it this
So use that 1, 2, 3, 4 up. They were all used up. And I've got that little guy, a remainder of 1 sitting there. You guys got a remainder of 1?
Yep.
Cool. Let's show it over here. Okay, whoops, that's a bad arrow. So Zeta, you said that 4 goes into 9 exactly 2 times. And that's where that 2 came from right here. They've got groups of 2. Yeah, 4 groups of 2. 4 times 2, yeah, 1.
Remainder 1.
Yep, and put our remainder up here, R1. I'm going to draw that arc, because I always think when I do my check, I'm really just going to check across the top here. 4 times 2 plus 1.
What?
Well, that's the check.
Oh, yours is closer.
Yeah, sorry. So I'm going to write my answer. The quotient is the 2 on top, the remainder is the 1, and then it's 4 times 2 plus 1. 4 times 2 equals 8 plus that remainder 1
It's 9.
equals 9. And then you've got the answer there.
I'm getting a star on all of these.
Now we're going to apply this to the last question on this page because it's now it's a double-digit number. So all we have to do is have 10s and 1 places here. We already know how many times 9 can be divided into 4. We're going to have a remainder of 110. Check it out and see if that doesn't happen. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2 in the ones. 1, 2, 3. We already know there's going to be a 2 here, 2 here, 2 here, and 2 here from the one above that just showed us that, right? We just did this problem. 2, 2, 2, and 2 with a remainder of 1. Now, let's look what we have to do with this one, because over here I'm going to slowly do it too. You say 4 goes into 9 2 times, and you're going to have a remainder of 1 here also. We used up 8. 1, 2, 3, 4, 5, 6, 7, 8. We have 1 left over, but it's not just 1 dot, it's how many dots?
10.
It's 10 dots, yeah. So we'd have to draw the extra 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means we've sent it over here. How do we show it here? We drop the 2 down, and we also have the number 12. 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 of them here. This also shows 12 here. A little quicker to just subtract and have a number come down than drawing all those dots. Now I'm going to ask myself, how many groups of 2, or 4, can we pull out of 12? Well, we can just do it the slow method. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Someone's turkey call.
Okay, so coming back from a pause here, I've got my dots, 3 in each one, so I think my answer is 23, no remainder. So I'm thinking these are 23, 0 remainder. If this is 23 dots, this is 23 dots, and there's 23 dots in here, equally shared, I should be able to add them back up to 92. I should have used all the dots, and they could evenly be divided by 4 with no remainder. To prove it over here, I'd have to do the long division. 4 goes into 9 2 times. I got the 1. That was my 1 dot right here. Moved it over and started calling it, instead of just 1, I began calling it 12 by bringing the 2 down, rewriting it next to it, and I said this is worth actually 12 complete dots, and that's where it came from. When you divide 12 into 4 pieces, you'll notice you get 3 in each one of those 4 groups, because 4 groups of 3 is 12. 4 times 3 is 12. Subtract, there's no remainder here. Okay, that sound good? Jackson, you okay with that? Yeah?
Hey, Mr. Leonard.
Yep. The quotient, yeah?
Can we go over 4?
Yeah, I will. Now, just a second, I'm just going to put the answer down here and we'll be done with this one. The quotient is 23. The remainder appears to be nothing, 0. To find out if you're correct, let's do the check, which I always say is just go over the top of the house here. 4 times 23 plus the remainder, which is 0. We don't even have to add the remainder in this one. We just have to do the 4 times 23, and we should get 4 23s add up to 92. Showing it multiplication, 23 times the 4, 4 times 23, should be 92. 3 times 4 is 12, carry the 1. 2 times 4 is 8, plus 1 is 92. We used them all up, so give yourself a star on that one. All right, what I'm going to do is pause the video, stop it,